Hello, welcome to this video. In this MATLAB video, we'll be looking at vectors and particularly just the introduction. What is a vector? A vector is a quantity specified by magnitude and direction. Magnitude refers to the significance or the weight of the quantity. The direction looks at where it's going or coming from. Now, some examples of vector quantities include velocity, displacement, and force, to mention but a few. Now, velocity is how fast a particle moves, but in a specified direction. Displacement is really a distance, but from a specific reference point. So there's direction coming in there as well. And so you can see for vectors, the direction is actually quite emphasized. Now, a vector could be three-dimensional or two-dimensional. And let's commence with 2D vectors. 2D vector can be represented on the xy plane, as shown below. This is the x-axis, and this is the y-axis. This is the origin. So we have a vector from that point, point P, its coordinates are xy, call that vector r. So we have the arrow to show that it's from the origin to that point, so point P. And you could write this as the vector OP, with that symbol just below OP. The vector r as x, y in column form like this, or you could write this as x times the vector I plus y times the vector j. The vector I is simply one step to the right, and the vector j is simply one step upwards. So x, the first quantity is for horizontal displacement, I would say, and then the second is for vertical. And so that's how we represent a vector. So if you had the vector 3i plus 2j, you could also write this as 3, 2. This would be 3 steps to the right and 2 steps upwards. So that would be the vector right there. And if you had negative 7i minus 8j, or negative 7 minus 8 like that, this would be 7 steps to the left and 8 steps downwards. So that would be your vector there. To the left, of course, because it's negative, and downwards also because it's negative. Now, these vectors can be added to each other and subtracted from each other. We'll simply operate with the like components. So say we had the vector A given by 5i plus 2j, the vector B as negative 3j, and the vector C as 4i minus j. If we had to add A minus B plus C, if we had to carry out this operation, this would be, let me write them in column form, 5i plus 2j minus negative 3j plus 4i minus j. In column form, that's what it will look like. So what we do simply is we have the 5 minus the 0 plus 4, and then 2 minus 3 plus minus 1. This gives us our final answer as 9, 4. 9i plus 4j. That's what that operation would be. So you simply just add the like components and subtract the like components when you're carrying out addition and subtraction. For scalar multiplication, if we had to get 2a, for example, this would simply be 2 times 5i plus 2j. The 2 multiplies everything inside, so this becomes 10i plus 4j. So the scalar multiplies the individual components. Okay, how about getting magnitude and direction? As you can see, if we have the vector r, the direction, and it's given by xy, so xi plus yj. In other words, x steps to the right and y steps upwards. Then the magnitude of the vector is in fact the length of the vector from that point to that point. And because we know that x steps to the right is simply, the vector xi, and the magnitude of this vector is x, because it's x times, x steps to the right. So it's just the length x. And then the magnitude of this vector is simply y, since it's y steps upwards. So the length of that vector, the magnitude of the vector, which is denoted like this, is in fact from Pythagoras' theorem, the square root of the sum of the squares of the other sides, x squared and y squared. And that's how we'll get the magnitude of a vector. And the direction, how do we get the direction? So that angle theta, from our knowledge of trigonometry, we know is the tan arc, the arctan of y out of x. And so if we had our vector, say, for example, 3i plus 4j, we know that the magnitude of this vector would be the square root of 3 squared plus 4 squared, which is 5. So 5 units, depending on what quantity the vector is. And the direction with respect to the horizontal would be the arctan of 4 out of 3. And so that's how we get the magnitude and direction of vectors. So that's basically it. We'll look at more in subsequent videos.